the inverse practice quiz that we did. I don't know when we did that, Monday, Friday, I don't remember. But it looks like this, the inverse practice quiz we did. Look, there's the Friday. Because on the back of it is today's. All right, so we got it. Here we go. Yep, we're doing the back of it. So tomorrow's quiz will look exactly like this. Thursdays, Friday, I don't know, whenever I see you again, that quiz is going to look just like this.
Miss, do you have a number?
Yeah. So it is going to have a random picture like this one.
Yeah, it is.
That's awesome. That is fantastic.
That's what, $450.
On a blue tag, which, who said that?
So here is the random picture from our parent graph that we're going to start with. On the quiz, it will be an easy one like this. In our notes, we had some harder shapes, you know, with semicircles and trapezoids and all kinds of stuff. It's going to be a real easy little shape, just like this. And then you're going to have to do two things with each problem. It says describe in words and sketch. So the first problem is this. So we have to describe in words what's going on. So what are the, I call them changes. What are the changes that are being made here in this problem? What's happening?
It's gonna be flipped first.
And when we say flipped, you have to be more specific. Flipped upside down. This is upside down. What is the sideways flip? I'll just make a list over here. The sideways flip is this, right? Right? Okay, so what else has happened? This has flipped it upside down, absolutely. What else has happened? It has gone where? Left one. Right there, that's left one. This would be up one.
Yep.
Right?
Yep.
That's left one. All right, and one more thing. What does that 2 do?
Multiply by 2.
Multiplies the height.
Multiply the height. You have to be specific. You can't just say multiply by 2. It multiplies the height by 2. Or instead of height, you could say y. Yep, and down. All right, so now you're going to graph it. And there is a lot in this problem, so I would suggest maybe one thing at a time, but it is up to you. I'm going to take every one of these points, left one. So instead of -4, I'm going to be over here at -5. And instead of -2, I'm going to be at -3. And instead of 0, I'm going to be at -1. So let's make sure everybody's keeping up with that. See what I'm doing? I'm trying to do one thing at a time. And I always start inside my parentheses. So that's going to be left one. I'm doing that first. All right, this point is at 1, so it's actually going to be at 0. And this is at 2, so it's going to be at 1. So there is my left one picture. I'm not done. Now I have to, bless you. Now I have to take of the y's, multiply them by 2, and flip them upside down. If you are a 0, timesing you by 2 won't matter, right?
No.
But if you're up here, if you're up 2, timesing you by 2 would put you up 4, but flipping you upside down would put you at -4. Now, if that's too much to do it once, do it in 2 separate steps. My y value right here is 2. I have to double it, makes it 4. But I have to flip it upside down, which makes it -4. All right, this y value right here is -2. It's gonna become -4, but then it flips and becomes +4. So the red thing is my answer. Okay? You're gonna have two of these on your quiz. It'll look just like this. All right, let's look at the second equation.
Sideways, I wanna know.
Second equation is negative f of -x plus 1.
Up 1, flip side.
So, yeah, you can list these in any order, it doesn't matter. You're gonna go up 1,
Mhm. Flip it sideways.
and you're gonna have a sideways flip. And we're gonna be specific. We're not just gonna say up, we're gonna say up 1. We're not just gonna say flip, we're gonna say sideways flip.
So we just say up instead of flip if he points off? Or like, if you say like up and flip instead of like up 1, or like
You
side.
have to say up 1,
Okay,
and you have to say sideways flip,
okay,
right? Because we can flip 2 different ways, and I need to know which way we're flipping.
okay.
All right, let's go back to the original picture. And I'm gonna do this in 2 steps. You don't have to, you can do it in 1 if you want. I'm gonna do a sideways flip first. So what that means is, here's my original. This point right here is left 4. So it's gonna be right 4. That point's gonna be out here. This point is left 2. It's gonna be right 2. Now that point's at the origin, so he didn't go anywhere, he's still not going anywhere. This guy down here is right 1, so now he's going to be left 1. And how does that look for my sideways flip? I'm not done yet. Okay? Now I have to take that guy and move him up 1, and it'll be on graph paper like this, so you'll be able to take it up 1 easily. So up 1, every point goes up 1. So the black guy is the answer to the question.
If we use 2 different colors on the test, you want us to erase our original line?
You don't have to erase, but just mark, this is my answer. Yeah, 2 different colors is fine. And you don't have to erase. Are we okay? All right, that's what is gonna happen next. I hate it when we practice and then we have that off day. So we'll have office hours in the morning. If anyone would rather come in and take the quiz tomorrow rather than wait till Friday, that's fine. You don't have to. That's fine. All right. Here we go. Let's get our notes out. If we have time at the end of the period, we still have our big extra practice sheet of graphing. We can do some of that. But,
Well, we can't.
yep, I got it. Yep. And we're gonna do some word problems.
You gotta get organized.
All right. Here I am on page 13, down at the bottom, 1.7. You don't have any notes? All right. Page 13, 1.7. Write an expression. All right, you've been doing this for a long time, right? You're doing it down the hall of the students class. Write an expression. 6 more than twice a number.
2x.
What do you think? He spouted that off right away. Everybody okay with that? 6 more than means plus 6, and twice the number would be 2x. Perfect. Love it. Very good. This one's a little tricky. 6 less than 4 times the number. 4x minus 6. Very, very good. Now, we've been using x's. Do we have to use x's? No, you can use whatever letter you want. 24% of a number. How do I express that mathematically? 24% of a number. Okay, you're very close, Gabby. It is times x. That's actually right. But how do I write 24%?
0.24.
What?
0.24.
2.24. So it's 0.24 times x. That's exactly right. So Gabby and Levi have both put together very important pieces here. First of all, the word of in mathematics means multiply. So when it says 24% of something, that's a multiplication. All right? And then Levi helped us out. We never ever, in any kind of problem, later on we'll be using some formulas for compound interest and stuff. We never ever use the actual percentage. We always put it in as a decimal. So 24% will never be 24. It will always be 0.24. 8% will never be 8. It will always be 0.08. Okay? All right. The final cost of an item, if the original price is X, there is a 15% discount and a 7% tax. Okay, wait a minute. So I go in to buy something that costs X. There is a 15% discount and a 7% tax. Now, would you agree that a 15% discount is minus 15%? And a 7% tax is plus 7%? Now, how do I express this mathematically? When you were younger, what you probably did was turn this into a 2-step problem, so, or 4-step problem actually. You probably found 15% of the cost and subtracted it. Then you found 7% of that new answer and added it. Way too much work. Way too much work. Here's how we're gonna approach these problems. We are going to do 2 multiplications.
It's right there.
Oh, thank you. These notes stay on the end very well. Okay. So we're gonna do 2 multiplications. We're gonna do no add and no subtract. Okay? Now, I go into the store, I'm gonna buy something that costs X dollars, and there's a 15% discount. If I am not gonna pay 15%, how much am I going to pay?
85.
85%. So we're gonna multiply by 0.85. Multiplying by 0.85 is a shortcut. You've subtracted the 15, but you didn't have to figure out what it was. 85%, I'm gonna pay 85%. Now, I gotta pay an extra 7% on whatever this is. Don't multiply by 0.07, because 0.07 will just tell you the amount of the tax. It won't tell you how much you're paying. Multiply by 1.07, because that is the original 100% plus 7 more percent. This number was 100 minus 15, because that's a minus. This number is 100 plus 7, because tax is a plus. Alright, so we are not gonna ever multiply by 15 or 7. We're gonna multiply by 100 minus 15 and 100 plus 7. Okay, we'll practice some. Alright, what will my salary be after a 7% raise? So right now my salary is X%. Let's suppose Mr. Matthews comes in someday and says, Lucy, you've been doing a great job. We're gonna give you a 7% raise. Wouldn't that be awesome?
Yeah.
Probably not gonna happen. But, what if it did happen? What would I multiply by to figure out my new salary if I was getting a 7% raise? Don't multiply by 0.07, because that would just tell me how much my raise is. It wouldn't tell me how much I'm making. It would just be how much my raise is. I want to know how much I'm making. 1.07, bingo. Why am I multiplying by 1.07? Because a 7 is a raise, right? So it's 100 plus 7. It's the original 100, 1, plus 7. Now, let's suppose he came in and said, Lisa, things aren't going very well. We're gonna have to cut your pay 7%. What would I multiply by if he were gonna cut my, what? 0.93, that's exactly right. How did he get 0.93? He took 100 minus 7, because if he is docking my pay, if he's taking money away, it's like a discount, right?
Yep.
So it's 100 minus. So basically what this says is, I would make 93% of what I made last year. Okay? Alright. Let's get down, while we're on this track, let's get down to H. We'll come back and do F and G in a minute. But let's do H. I have an item. I don't know, the original price is X. There's a 20% discount. So what am I gonna multiply by if there's a 20% discount? 0.8. Right? But then, again, I live in Indiana, so I have to pay a 7% tax. So 1.07. Now, don't say 1.7, because 1.7 would be a 70% tax.
Yeah.
Oh, yeah.
So we need 1.07. Alright, in a minute we'll do some with real numbers, but we're just kind of getting the hang of it. Alright, F and G are not money or percent or anything. I have a rectangle, and I know the width is 3 less than the length. The width is 3 less than the length. Can you label these sides for me? If the width is 3 less than the length. If I call the length x,
It's -3.
this would be x minus 3. Is that all right with everybody? And I have to write a formula or an expression for the area. How do I find the area of a rectangle?
It's x multiplied x minus 3.
X times x minus 3?
Yep.
Or x squared minus 3x if I distribute it out?
Seems not right.
How about another rectangle? And this time, the length is twice the width. The length is twice the width. So call this x and this 2x maybe?
Yeah.
Remember, you have to call something x. Pick something to call x. And then the other one, you'll know from the problem what is. Now this time I don't want area, this time I want perimeter. Perimeter means
3x.
add up
All the sides.
all the sides, including these two, right? So x and 2x and x and 2x is gonna make a total of 6x. All right, let's get our calculators out and let's go do some problems then. All right, your favorite teacher received a 3.2% salary increase. If her original salary was 1, 2, 3, 4, 5, what is her new salary? So here's my original salary. What am I going to multiply it by if I am going to get a 3.2% increase? We're adding on 3.2%. What am I gonna multiply by? Would you say 1.032?
032.
Very good, Frank. Very, very good. Now, first of all, do you understand why we added on? Why it's 1 point? And how did .032 get in there? Well, remember, when you do a percentage, you move the decimal point how many places?
2 times.
2. That's where the .032 came from.
How'd you get the 1 in front of it?
Because it's 1 plus. Remember, I erased it all over here, but Gabby, we never use the percentage. It's 1 plus if we're adding on, or it's 1 minus if we're taking away. If it's a discount, something's on sale, it'll be 100 or 1 minus 10% or whatever you're taking off. Okay? Gabby, I want you to think about this for a minute. What happens to 12,000 if you multiply it by .032? Does it get bigger?
It gets eaten up by the next
No,
one.
it gets teensy-weensy, right? I wanna know my new salary. I don't want you multiplying by .032. That's gonna cut my pay by almost 97%.
Yeah.
Right? Or a little, yeah. I need you to add that on, so it's 1.032. To give me my original 100% and then 3.2% more. All right, then I can type it in my calculator.
12,740.
And what is my new salary?
12,740.
Oh, is that?
And four cents.
Actually, 12,000.
12,000.
You're good at numbers, you should be able to forget it.
Sorry, what you
There
said?
we go. So there is my new salary.
Do you want us to add a
I
decimal?
actually used to do these problems in
Do you want us to add a
grade school.
decimal?
Yeah, when you have money, we go to the hundreds,
So for
Okay.
because that sense.
Okay.
All right, last year, a pre-cal book cost $89.50. This year, it costs $97.75.
Ooh, that went up a little.
Inflation.
We wanna find the percent of increase. You learned how to do this before, there's a little formula for this, it was a long time ago, do you happen to remember what it is?
Just a guess,
Is it-
do we subtract the two numbers first?
You do, Mr. Ayers, and then what?
And then you do something with 97.75 and the number you just got.
Okay, you're very, very close. The first thing we do is find that the percent of increase is gonna be the difference. So like you said, we're gonna subtract those, and it's divided by the original value. Okay, so the difference will be 97.75 minus 89.50, whatever that is, I can figure it out on my calculator. And then divide it by 89.50. So anytime it talks about percent of increase or decrease, because sometimes things go down, that's your structure. Like he said, find the subtraction. And I got 825. Did you? And I'm gonna divide that by 89.50. Always divide by the original value. And I got 9.2%. Now, when I typed it in, I got 0.092. I am finding the percent though, so how many decimal places?
2.
2, so that's how I got 9.2. So basically what that means is, from last year to this year, the price of the book went up 9.2%. A car that was worth 2, 3, 4, 5, 6 when you left the lot is now worth 18,765. So we started at 2, 3, 4, 5, 6, and it went down to 18,765. And we want to know the percent of decrease. All right. What do? Got it right there. We find the difference. So that'll be 2, 3, 4, 5, 6 minus 18,765. And then we divide it always, always, always by the original. So 2, 3, 4, 5, 6. And that's gonna tell us what percent the value of our car went down. So I got 4,691. Did you get about 20%?
Yeah.
I got 19.999, so I'm gonna make that 20%. So this car went down in value about 20%. Alright, sticking with the theme of money, I'm gonna go to letter F next. We'll get them all, I promise. But I wanna go to letter F next. We got a sweater that costs $52.50. It's on sale for 25% off. And there's a 7% tax. Now, when you think about this, we talked about it earlier. If something is, if we're taking away 25%, then what are we gonna multiply by?
0.75.
0.75. This is 100 minus 25. We always start with 100, the original value, 100%. And then we do whatever we do to it. So in this case, we're subtracting 25%. Now, then I gotta pay tax. What do I multiply by here?
1.07.
1.07, because I have to add on the tax. I start with my 100%, I have to pay for the item. But then I have to pay an additional 7%. And we can just type it in on our calculator. So 52.50 times 0.75 times 1.07. Round that off to the nearest cent. I got 42.13. What about you?
Yep.
So when I go to check out, I'm gonna end up paying $42.13 for this thing. Alright? Number G. Find the final cost of your restaurant meal. If the food costs $23.12, there's a 7% tax, and there's a 15% tip. Now, is a tip an add-on or a
It's gonna be an
takeaway?
add-on.
It's an
You're
add-on.
adding.
So this problem has two add-ons. No discounts. Adding on the tax, adding on the tip. So, what am I gonna multiply?
1.07.
1.07. In Indiana, you're always gonna multiply by 1.07. How about here? 1.15. Because I have to pay for the meal, you guys, and then I have to pay an additional 15%. So the 100 is the original. That's whatever you're buying. And then this is what extra you have to add on to it. So how much is this gonna cost me?
28.45.
Oh, yeah.
28.45.
28.45 is
Yeah.
what I want. And does that look okay? 28.45?
Mm-hmm.
No, I'm supposed to say 22 cents. No. You don't.
Alright? And one more quick one before we move on to a different type of problem. Let's say I go into the restaurant, I buy, the food I order, whatever, costs $32.18. I gotta pay tax, 7%. I gotta leave a tip, 20%. But I have a coupon,
Oh,
I have a coupon for 30% off.
0.7.
Take a minute, figure out how much that food's gonna cost me. You can figure it out. Alright, so I got tax, I got tip, I got coupon.
Seven.
Who's got an answer? Anybody? Yeah. 28.92. How's that sound?
Sounds good.
Yep.
Sounds great.
That coupon really helped.
That coupon really helped, yeah. So Amaya's like, can't figure this out. So let's help her. Alright, so I start with 32.18, and I'm gonna multiply by 3 things because I am making 3 adjustments to my cost, right? One of the adjustments I'm making is a 7% tax. That is gonna be 100 plus 7 or 100 minus 7. Those are your 2 options. 100 plus 7, 100 minus 7. Which is it?
Plus.
Plus. So 1.07. Now the tip, 20%. It's either 100 plus 20 or it's 100 minus 20. Which is it?
Plus.
Plus. 1.20.
Yep.
And then a coupon. It's either gonna be 100 plus 30 or 100 minus 30. It'll be minus because a coupon comes off, so that's gonna be 0.7. Oh. Think about it like this. You aren't paying 30%, so you are paying 70%. And when you go up to pay, they want to know how much you owe, not how much you got off. That doesn't matter. How much you still owe? You owe 70%. And they just multiply it all together, right? Alright, we have 2 more kinds of problems we need to look at. One of the kinds of problems we have to look at is our box problem. So let's go back up and look at letter D. We're still on page 14, we're on letter D now. We have our piece of paper, and we're gonna cut the corners out. Did we do these earlier in the year? We didn't?
This year, no. Not that I recall.
This is
I
the
don't
first time
recall
we've
doing
done that.
Yeah.
Is it quantum physics?
That's weird. Okay. What was I doing? I don't know. All right, so here's the deal. We'll start at the beginning. I have a piece of paper that's 12 by 14. Okay? 12 by 14. I have decided that for whatever reason, I need a box. So I am going to cut corners out of my paper. See what I'm doing? I'm cutting corners out of my paper, trying to make them sort of the same size. And then I'm gonna fold up these, so now my paper looks like this. I'm gonna fold up the flaps. And I'm gonna have a box, see that? That's what we're doing, we're making a box.
Oh, nice box.
Now, when I make this box, next period, it's not gonna look just like this. Because the corners that I cut out, the size of the corners, kind of determine the shape of my end box. Would you agree with that?
Yes.
So if he makes a box, and he makes a box, and I make a box, even though we all start with the same paper, our boxes might look different. Agreed? My job today, your job, is to figure out how big of corners you should cut out to make this box hold the most volume that it can. Okay? So he made a box, I made a box. I come around with a huge bag of M&Ms. I dump M&Ms in his box, I dump them in his box, I dump them in my box. I want the box that holds the most M&Ms. Right? So how are we gonna do that? Well, here's how we're gonna do it. We're gonna say that the size of these corners is X. We have no idea how big those are. We're gonna cut them out. And we're gonna fold up the flaps. So here are the folds. So you gotta visualize it. I've got a visual right here for you. But you gotta see that. So you see that up here? I want the volume, spell it right, the volume of the box. Now, does anybody know from geometry how to find the volume of a rectangular solid? What's the formula? Don't say pi r squared, that's a circle. Who remembers for a box? Real easy one.
Base times height.
Length times width times height. Well, base times height. Base is length times width. So length times width times height. Okay, so that's my formula. Now, in the beginning, whoa, just over here, shoot. In the beginning, the length of my box was 14, but it's not 14 anymore.
No,
This is the length now, right? So what is it? It's not 14. 14 minus something. Not 1x, but 2 x's. Because didn't I cut an x off here and then here? So 14 minus 2x. Good. That's our width, or length. Now, in the beginning, the paper was 12. But this is not 12. What is that? 12 minus 2x. And then I folded these up. This is the height of the box, right? Well, what's that? What's the height of the box? Isn't that just x? So there is my formula for the volume of my box. Alright, now, before we go any farther, we're gonna talk about one more thing. We're definitely gonna be using our calculators next time. So let me talk about one more thing. In the next problem, it's a repeat, copy and paste, but now the paper is 20 by 24. What's gonna change in this formula? Is anything gonna change?
you switch out your 14 and your 12 for 20 and 24.
Instead of 14 and 12, I'm gonna have those numbers, but it's still gonna be one of the numbers minus 2x, one of the numbers minus 2x, and then x. No matter what. This will be a final exam problem, and a test question. That formula never changes. Just the size of the paper changes. All right, last thing we have to talk about is what's the domain. Now, the domain or the limitation on X. So remember, X was the size of the corners I cut out. So I want to know, are there any limitations on X, or could X be anything? Is my domain all real numbers? Negative infinity to infinity. What do you think?
I don't think it can be.
What do you mean?
Because doesn't it have to be 14 or 12? And like,
Okay, so he's saying, I think what he's saying is, okay, wait, if my paper's only 14 by 12, X can't be 100, right?
Yeah.
So what can X be? Can't be 100. Can it be 12?
yeah.
Actually, no.
Oh,
Because remember, you're taking it off both sides.
Yeah.
So if it's only 12 total, and you have to take a piece off each side, then the biggest it could be is
12 minus 2x.
6.
Oh.
6. Let's talk about one more time. This is 12 all the way across. I'm gonna rip a piece off this side and a piece off this side. Now, could I rip 1 inch off here and 1 inch off here? Yeah, because that would leave me with 10. Could I rip 5 off of here and 5 off of here? Yeah, that would leave me with 2. But wait a minute, what if I rip 6 off here and 6 off here? It was only 12 to start with, guys. If I took 6 away and 6 away, I don't have anything left,
Yeah.
right? There's nothing left,
That's what it has to
because there's only 12 to start with. So it can't be 6, but it can be everything up to 6. So the upper limit is going to be 6. Now, is there a lower limit?
Yeah.
What? No? Negative infinity?
No, it's zero.
Zero. There you go. Kids, can this be negative inches?
No.
No. It's gotta be some inches, right? If I'm gonna make a box, so it's something bigger than 0 and something less than 6. Now, the rule. Remember we talked about this equation is never going to change. Whatever the paper size is, you'll stick those numbers in. But otherwise, that's your equation for the volume of the box. This is never going to change. This is always going to be 0.
Half,
And this is going to be what?
half of it.
Half of what?
The
Smallest
number.
dimension. So this is going to be half of the smallest dimension. So my paper was 12 by 14. The smallest dimension is 12, and the upper limit of X will always be half of that number. All right?
Will you ever have a decimal?
Could be, I mean, if that were 15, but, got it? All right, we're gonna stop there, and we'll pick up with this, next time. So after we take our, right. So we do have office hours tomorrow and Friday, if you are so inclined. You could come in and practice.
And we're all sitting there, I'm like,